Hello, greetings to everyone and welcome to Acadex Higher Engineering Academy, building your engineering career. Today in this video, we're going to continue with the solution of FET BUEA of Mathematics of 2018, and we're going to continue with part 2 solution. I remember uploading the part 1 solution of this paper of this video, and I'm going to continue today from where I ended with part 1. Therefore, I urge you to browse down the channel and watch part 1 solution, then you come and continue with part 2 if you have not yet done so. However, for the sake of self-presentation, I am Sir Godwill Yakum. Let's get started with question 1. It reads, find the integral of this boy, 3x over 1 plus x squared dx. So, let's analyze the question and start solving. So, to solve this, we can simply go by means of substitution. We can let u to be this boy in the denominator, 1 plus x squared. Yeah, and if we let u to be 1 plus x squared, it means that du dx, if we differentiate the u with respect to x, we're going to have 2x, and then we can cross multiply to have dx equal to du over 2x. Alright, then our integral that was given to us was 3x over 1 plus x squared, where we let 1 plus x squared to be u. It means we are left with the in fact we are going to have integral of 3x over u dx, and then dx we have already we have that dx is 2u over is du over 2x, and that's what we're going to substitute here to have this 3x over u times du over 2x, and then we're already seeing that x is going to cancel, and when x cancel, we're simply going to have now the integral of 3 du over 2u when we multiply, 3 du over 2u when x has already cancelled, and this is going to give us 3 over 2 times the integral of du over u when we factor out 3 over 2, and we're left with du over u. And we already recognize that du over u, the integral of du over u, is equal to ln u. If you don't know that, then you need to master that now. The integral of du over u is ln u. So that's what gives us 3 over 2 ln of u, then plus k, which is the constant of integration. Now, but our u was 1 plus x squared, so we'll fit it in 3 over 2 ln u, and u is 1 plus x squared, then plus k, which is the constant of integration. Now our answer is in option D. Option D has the correct answer. Okay, let's proceed to question 2. This is question 2, and here are the options. Given that y is equal to 1 plus 2x raised to the power half, then dy dx is, we are looking for dy dx, meaning that we are going to differentiate this function y with respect to x, and then we are going to have our dy dx. Simple. And then this is how we are going to do it. Let's just analyze the question, and then we start solving. We have that y is equal to 1 plus 2x raised to the power of half. Now, to differentiate this, there are principally two methods, or even more. There are two methods we can solve this. but I'm going to go by implicit differentiation, because I will recognize this as a function of the as a function of a function. And then because I have an inside function and I can let the inside function to be u, it means I have u equal to 1 plus 2x. And then let me differentiate u with respect to x. I will now have du dx equal to 2, because when I differentiate 1 with respect to x, I have 1 is a constant, I have 0. When I differentiate 2x with respect to x, I have 2. So that's why I have dy dx, du dx equal to 2. Now, when I let u to be 1 plus 2x, y becomes u raised to the power half. So y is equal to u raised to the power half. And then now, what is dy du? If y is equal to u raised to the power half, I need to differentiate y with respect to u, and I will have half u to the power half minus 1 from the normal principle of differentiation. I'll drop the power and I'll subtract 1 from the power, and this gives me half u raised to the power of negative half. Now, in implicit differentiation or function of a function, this is how we get the exact derivative of dy by dx. We simply introduce a parameter which does not change anything. So we have introduced du, and at the end was from here we can already see that this still gives us our dy dx. So we have introduced a parameter that does not affect anything. Alright, so you need to master this if you have no idea about it. So dy dx is given by dy du times du dx. We have du dx here and we have dy du here, and that's we're simply going to multiply. Now dy dx is equal to, we have half u raised to the power of negative half, which is dy du. Then now times du dx, and du dx is given as is equal to 2. Yeah, it's equal to 2. We solved it to have 2, and then we multiply this. 2 will cancel here, and we're left with u raised to the power of negative half. And we know that u is equal to 1 plus 2x, that we let u to be 1 plus 2x here. So u is equal to 1 plus 2x, and then we'll fit it here. So our dy dx is u raised to the power of negative half. U is 1 plus 2x, so we have 1 plus 2x raised to the power of negative half. Raised to the power of negative half. Alright, so I think from there now we can proceed. 1 plus 2x raised to the power negative half. Let's see the answer that is correct here. This one is wrong, this is correct. So option B is correct. Option B is correct. Option B. Okay, question 3. Question 13. The general solution of the differential equation cos x dy dx equal to y sin x is A, B, C, D. Alright. So this is the solution here. This is the solution. Well, when we look at the differential equation cos x dy dx equal to y sin x, we notice that this is a first order variable separable differential equation. So we can simply separate the variables and integrate, and then life becomes easy. From here, let's cross multiply to have that cos x dy is equal to y sine x dx. After the cross multiplication, we have this. Now we divide all through by cos x. If we divide all through by cos x, we have dy to be y sine x dx over cos x. And then from here now, we can divide all through again by y. And we have dy on y, or we have 1 on y dy is equal to sine x over cos x dx. Now let's integrate both sides. We integrate here and we integrate here as well. And we're going to have the integral of dy over y equal to the integral of sine x over cos x dx. And then working with the right hand side, we want to we know that the derivative of cos x is negative sine x. The derivative of cos x is negative sine x. So if we can introduce a negative here, then it will be easy for us to just to save our time, because we are seeing the ln. We are seeing our answer here in terms of ln. So now, from here, since the derivative of cos x is negative sine x, we can introduce a negative here and also a negative here. It's just like negative negative, which still cancels out its effect. So now, if I put a negative sign here and negative sign before the integral, I'm good. Now I have that the derivative of cos x is negative sine x, and therefore the integral of negative sine x over cos x must be the ln of cos x, the ln of the denominator. So remember, in the previous question we saw something similar to this. We already saw that when we are integrating du over u, we are integrating the derivative of a function divided by that same function. We have the ln of the function itself. So that's why here we're having the ln of cos x. Attach a negative to it, negative the ln of cos x, now plus the constant of integration. And this is the same thing here. We have dy over y, and when we integrate dy over y, it's the same like integrating du over u to have ln u. So integrating dy over y, we have ln y. And then I think check here, we have ln y equal to negative the ln of cos x plus k, constant of integration. So option D has the correct answer. Question 14, limit as x tends to 2 of this. Let's start solving. Limit as x tends to 2. We are simply going to, first and foremost, we have evaluating the limit of this function as x approaches 2. We have to insert 2, direct substitution. We are going to insert 2 by direct substitution into this function. If it gives us a value, fine. If it does not give us a value, then if we have an indeterminate form, then we now proceed to remove the indeterminate form so as to have a limit. Remember, the limit as x approaches 2 of this function is the value of this function as x is coming to 2, as x is getting closer to 2. Alright, now, so the first thing is to do direct substitution, and if it gives us an answer, then we'll box it and we'll leave it there. But if it does not give us an answer, if it gives us something that is indeterminate, we have to now go by other means to remove the indeterminate form. When we substitute 2, we are going to have this. And from here, this is 4 minus 2 minus 6. Alright, 4 minus 2 minus 6, that's negative 4. And then 2 plus 5 times 2 plus 2 is 4. So here we are going to have negative 4 over 28. We divide all through by 2, or we simplify by 2. If we simplify top and bottom by 2, we have negative 2 over 14. Simplify again by 2, we have negative 1 over 7. In fact, so it makes it easy. We have already seen that the answer is D. So it is not indeterminate. Question number 16. Here we have a question on complex numbers. We have 1 minus I over 1 minus 2I. And then how can we solve this? How can we solve this? The only way, or not the only, there are always so many ways to solve a question. We can try, we can solve many ways, like 2 ways, and we're going to have the same answer. This question has to do with complex numbers, and then to solve this problem, we need to be able to rationalize the denominator of this complex number. And how do we do that? We need a conjugate of the denominator. What's the conjugate of a complex number? The conjugate of a complex number is gotten by changing the sign of the imaginary part of the complex number. Given that this complex number 1, given this complex number 1 minus 2I, 1 is the real part of the complex number, and negative 2 is the imaginary part of the complex number. Negative 2I, yes, and I that's attached to it is imaginary. So now we get the conjugate of this complex number by changing the sign of the imaginary part. So we are going to change the sign of the 2I. Negative 2I become positive 2I. That's for the conjugate. And what do? We now multiply top and bottom by the conjugate of the denominator. So watch what we are going to do here. We have 1 minus I over 1 minus 2I. It's going to be equal to, now the conjugate of this we said is 1 plus 2I. So we are going to have 1 minus I times 1 plus 2I. And then the same thing will multiply here in the denominator, 1 plus 2I. 1 plus 2I. Alright, so notice that we have changed nothing if we multiply up and down by 1 plus 2I. When we do that, we are going to have 1 times 1, 1, plus 2I minus I, which is plus I. Then 1 times 2I. Negative I times 2I. We are going to have negative 2I squared. And I squared is negative 1. So negative 1 times negative 2 gives us plus 2. This is because I is equal to the square root of negative 1. And since I is equal to the square root of negative 1, I squared is the square root of negative 1 all squared, which is negative 1. So I hope it's okay for everybody here. And the denominator, the same thing happens. We're now going to have 1 plus 2 is already 3, so we have 3 plus I over 5. And then we can partial fract this by sides. Partial fracting by side, we have 3 on 5 plus I on 5. Or we have 3 on 5 plus 1 over 5 I. So that is it. We check here to notice, we see that A is the option that has the correct answer. We continue now to the next question, which reads, given that y is equal to x ln 3x squared, the value of dy by dx when x is equal to 1 is A 3, B ln 3, C 1 plus ln 3, D 2 plus ln 3. So let's start solving. We are given the function y equal to x ln of 3x squared. So we are going to differentiate this. We are going to differentiate this function of y, and we can differentiate this by using product rule, and by product rule, y prime is equal to uv prime plus vu prime. So we are going to let a function there to be u and the other one automatically to be v. So let's let u to be x and v to be 3x squared. Now we have that here y is equal to y is equal to the ln of f of x. Then if y is equal to the ln of f of x, then y prime, which is dy by dx, must be equal to f prime of x over f of x. Yes. So since we have that v is the ln of 3x squared, it's not just 3x squared. V is, we are letting u to be x, and then we are letting v to be the ln of 3x squared. Now we need to differentiate u and also differentiate v, both with respect to x. Now, and we know already that if y is equal to the ln of a function, ln of f of x, then y prime, which is dy by dx, will be equal to f prime of x over f of x, which is the derivative of the function divided by the function itself. Now it means that we are going to have when we differentiate this, we are going to have 6x. Then we divide it by the same function 3x squared. The derivative of this will drop the power. 2 times 3 here will give us 6, and then we'll subtract 1 from the power, so it's 6x to the power 1, which is 6x. Okay, so we are having that y prime is equal to we are going to take uv prime, where u is x, times v prime. We differentiate v, which is the ln of 3x squared. So when we differentiate the ln of 3x squared, we have 6x over 3x squared. So this is it. So this is u v prime, which is x times this, plus v u prime. Now we are having the ln of 3x squared times the derivative of x, which is 1, and it maintains the number the same. Okay, now from there we have that y prime is equal to 1 plus the ln of 3x squared. But we were told that we were asked to look for that derivative at a certain point, at a point x equal to 1. So we are going to substitute that value of x to be 1, and then we are going to have y prime to be equal to 1 plus the ln of 3, because 1 squared is 1 and 3 times 1 is still 1. So we have our y prime to be equal to 1 plus the ln of 3. So our option C has the correct answer. Even though here is B, is because I doubled the A, so it's a typing error. Option C here has the correct answer. Okay, now we continue with the next question, which also has to do with complex numbers. Now the modulus of the complex number 1 plus the square root of 3i over 1 plus I is, so we have 1 plus root 3I over 1 plus I. We need the modulus. Now, the easiest way and the most convenient way to look for the modulus of this complex number, there are many ways of course, but we can simply look for the modulus of the numerator separately with the denominator. We look for the modulus of the numerator separately and then the denominator separately. Then we divide the two functions. Otherwise, you go by rationalizing like we did in the previous questions, around question 16, something like that. Then you from there now you look for the modulus. But what we are going to do in this video, we are going to start by finding the modulus of the top, modulus of the bottom, then we divide. And the properties of modulus is one of the properties of modulus of argument of a complex it is one of the properties of the modulus of a complex number. So we are going to look for the modulus of 1 plus root 3I, which is simply 1 squared plus root 3 all squared. And when we do this, it's going to give us root 3 squared is 3 plus 1, 4, 2. And the square root of 1 is, the square root of 4 is 2. Now, for the denominator, we have the modulus of 1 plus I, which is the square root of 1 plus 1, which is equal to root 2. So therefore, the modulus of this complex number, 1 plus root 3I over 1 plus I, the modulus of the whole complex number will be equal to the modulus of the top, which is 2, divided by the modulus of the bottom, which is root 2. So our answer is 2 divided by root 2. We can find that answer in C. We can find it in C. But now, if there was any answer there like root 2, it would have been the most correct answer. Why? It is never good to leave a square root function in the denominator. So we could still multiply top and bottom by root 2, and when you multiply top and bottom by root 2, you are going to have 2 root 2 on 2, and the 2's will cancel and your answer will be root 2. So in case this one was there and root 2 was there, then the correct answer will be root 2. Therefore, in 2023 or the years to come, they can give a similar question, and then instead of giving an answer that corresponds to this, they may give this in the option, and if you don't know this, then you may not be able to get the mark. Alright, I think this is question 20. It still has to do with complex numbers. So the question reads, the complex number this can be expressed in the form a plus bi, where a and b are real numbers as. Alright, so we need to express this in the form a plus bi, where a and b are real numbers. And then to do this, we can see this thing in the form of cos of a certain theta plus I sine of the same theta raised to a certain power. The only way we can solve this, we can use the Moivre's theorem. The Moivre's theorem. We all know about Abraham de Moivre. So now, from his theorem, a complex number z can be written as cos n theta plus I sine n theta raised to the power b. And if so, then that same complex number z can still be written as cos bn theta plus I sine bn theta. That means the power can simply drop and multiply the theta on the real and the imaginary part. So that's what we are going to do. That's what this is the principle this is the principle that we are going to use to solve this problem. So I'm going to have cos, here we have cos pi on 27 plus I sine pi on 27, all that times 9. So when the power drop, when the 9 drops, it's going to multiply here and here. So I'm going to have the cos of 9 pi over 27 plus I sine of 9 pi over 27. 9 over 27 is equivalent to 1/3. So we are going to have the cos of pi on 3 plus I sine pi on 3. Now pi on 3 is the same like 60 degrees, and cos 60 is half. Yes, cos 60 is half, and sine 60 is root 3 on 2. So from there we're going to have that this is cos 60 plus I sine 60, which is half, plus I root 3 on 2. So we are going to have half plus I root 3 on 2. And we can find this in option D. Option D has the correct answer. Alright, ladies and gentlemen, here we come to the end of our tutorial video for today. This is not actually the end of the FET mathematics section of 2018. I may still continue again. Surely I shall continue in subsequent video. I'm going to continue from where we end today. Therefore, as you have already subscribed to the channel, if not, you do so. Subscribe now so as to receive notification when I upload the next video, so that you come and watch. Alright, so study well, study hard, and be focused and determined as you prepare for your concours.